Hi, friends. In this lecture, I am going to discuss problems. Let us see first one. A block of mass M is attached with a massless spring of force constant K. The block is placed over a rough inclined surface for which the coefficient of friction is 3 by 4. The minimum value of M required to move the block up the plane is. So we have to neglect mass of the pulley and spring mass and friction in the pulley. Right. So condition is that we have to find minimum value of capital M so that this is about to move upwards. Okay. So when this is about to move upwards, friction will be downwards and that will be limiting value. So first focus here. If it has to move upwards, spring force should balance weight component and limiting friction. Okay. Let us see the calculation part. Right, first make the diagram given. Angle given is 37. Angle of inclination. This is a small m connected to spring, which is passing over a pulley. And this is now capital. Now see the condition. For this block to move up, condition given that minimum value of m. So when it is a minimum, this is about to move upwards, not moving, about to move. That means if its value is slightly greater than that required minimum value, then this will move upwards. Okay. Now see condition about to move upwards. Spring force. Spring force will be kx supports. Spring force kx supports. Since it is about to move up, friction will be down. And that will be limiting value. And weight component is now mg sine 37. So about to move. So condition is spring force is able to balance weight component mg sine 37 limiting friction mu into normal reaction. It's actually mu s. So mu s into normal reaction is mg cos 37. This is now condition. Now, since it is having elongation x, this will come down by distance x. And we can see when this comes down by x, it will come to rest temporarily. Because when this is not moving, it is just like a fixed one. So elongation will be maximum when this block comes to rest temporarily. So when elongation is maximum, with minimum mass, we can move this one. So condition is when mass is minimum, here elongation will be maximum. For that, it is about to move upwards. So for this condition is now, it comes down by a distance x before coming to rest. Starting from rest, finally also comes to rest temporarily. That means for this one, delta K equal to 0. That means we can write loss in its gravitational potential energy converts into spring potential energy. So it is condition mgx, that is loss in its gravitational potential energy, that is converting into spring potential energy, that is a half kx square. Now see here what we can do. X gets cancelled. Kx is equal to 2mg. Substitute that now in this one. In the place of kx, writing here 2mg. That is equal to here mg, here mg. I'm taking outside. Remaining is now 3 by 5 plus, and see mu value. It's actually mu s. It is 3 by 4. 3 by 4. And cos 37. That is 4 by 5. G gets cancelled. 4 cancel. 3 plus 3 is 6. It is now 6m upon 5. Okay. And 2 here. It is now 3 times. That means minimum value of capital M, okay, is 3m upon 5. So first condition, it is a force equation for this one. Mostly in this, there is no confusion. Mainly confusion comes how we have taken this equation. Okay. So since we are taking minimum, so this will move when this is a coming to rest. Okay. That is a key point which we have to understand. Let us see next one. So option is, it is A. Right. Now coming to next one. Let's see the question given. System shown in figure is released from rest. Pulley and spring are massless and friction is absent everywhere. The speed of 5 kg block when 2 kg block leaves the contact with the ground is spring constant given G value 10. So condition given that released from rest. That means we have to understand that initially we are holding 5 kg block, okay, so that 2 kg block is in contact with ground and spring in its natural state. Then we are releasing 5 kg block, okay. Let us see. We have to focus speed of 5 kg block when 2 kg block leaves the contact with the ground. Okay, first make the diagram given. This is now 5 kg block. And coming to here, so taking a 2 kg block and see spring constant given, that is a 40 Newton per meter. Right. Now see the condition. When 2 kg block losing contact, that means its weight is balanced by spring force. Its weight is balanced by spring force. Weight equal to mg, that is 20. Okay, 20. And k value 40. That means x value kx equal to 20. K value 40, that implies X value, it is a half meter. Okay. So here we assume that Hooke's law is valid. That means spring force is K into X. Okay. Right. When X equal to half, now we can see coming to 5 kg block, one is the spring force that is upwards and mg downwards. Then see what we can write here. If you are taking now work energy theorem, for 5 kg block, initially velocity is 0. Final velocity we have to calculate. Means delta K we have to focus. Gravitational force, which is a constant force. Spring force, which is a variable force upwards. But displacement is downwards. So I'm writing here net work is equal to delta K by gravitational force. Gravitational force mg, displacement is half. Displacement is downwards. Gravitational force also downwards. So by gravity, positive work is done. Coming to by spring force upwards, but displacement is downwards. So it is minus half kx square. Half kx square. So 1 by 2 whole square. Okay. That is equal to half m v square. Initial value 0. And remain just calculation part. We can see this is 25 and here 4 10 times, and this is now 5. 25 minus 5 20. 20 equal to 5 by 2 v square. 5 here 4 times 4 to 8. That means v value, it is a 2 root 2 meter per second. Okay. So writing force equation for 2 kg block and next taking work energy theorem for 5 kg block. Okay. So answer is it is option B. See next one. A smooth track in the form of a quarter circle of radius 6 meter lies in the vertical plane. A particle moves from P1 to P2 under the action of forces F1 bar, F2 bar and F3 bar. Force F1 bar is always towards P2 and is always 20 Newton in magnitude. Force F2 bar is always act horizontally and is always 30 Newton in magnitude. Force F3 always act tangentially to the track and is of magnitude 15 minus 10 s Newton. Select the correct options. We can see diagram here. P1, P2. Radius is given 6. This is 1/4 of a circle. So we have to calculate now work done by F1, F2, F3. And coming to F3 bar is a conservative in nature. We can see F3 always tangential, right? Okay, let us see first how to calculate now work done by all these forces. Right. So first of all, note on the given data. F1, its magnitude is 20 Newton. Always towards speed. Always towards speed. Coming to F2, it is 30 Newton. It is always horizontal. And coming to F3, it is given always tangential. Its value 15 minus 10s, where S stands for distance traveled, Newton, always tangential along a tangent. Okay, let us make a diagram. Right. This is now P1 and this is P2. Radius is given R equal to 6 meter. So first thing in this, we can calculate work done by F2 directly because it is a constant force, the same magnitude, same direction. Then focus displacement along horizontal. If you focus on displacement horizontally, it is equal to R. Okay. Applying for 30 always horizontal like this only. Always. So from P1 to P2. So displacement component along horizontal is 6. Therefore, we can say directly work done by F2, that is equal to 30, displacement 6, 30 always right side horizontal, displacement also right side. We are focusing here displacement component along horizontal, it is also right side. That means it is now 180 Newton. So this we can see directly. Next. Now focus by F3. Coming to F3, work done. It is a variable force. So I'm taking an iteration. Take it as W3. Iteration of F bar dot ds bar. Take a small displacement ds. Okay. Since it is always along a tangent, force always along tangent, displacement also along tangent. Okay. So between these two angles now 0. So integration of 15 minus 10s into ds limits. Distance traveled 0 to distance traveled is nothing but length of the path. That is now arc length, right? So arc length equal to pi r by 2. So it is now 0 to pi r by 2. Now see calculation part. 15 s minus 10 s square by 2. So 15 s minus 5 s square. Now in this take limits. Okay. So taking limits now 0 to pi r by 2 and r value 6. And after making calculation, so we are going to get, it will be minus 302.8 joule. Okay. That is what we are going to get after making the calculation. So by F2 and by F3. So calculation is now very simple and the direct one. Now focus because of F1. Okay. Now see carefully. Let us take at one instant. This is location of the particle and force is always towards P2. Therefore, I am drawing a line joining P2 and this particle. Force is now always towards P2. This is now direction of P2. Sorry, direction of F1. Okay, direction of F1. And displacement. We are taking a small displacement that is along a tangent. That means angle between displacement vector and force vector. Displacement along a tangent. This is now ds. And between these two, suppose angle is now theta. Between force vector and displacement vector, suppose angle is theta. Now see what happens. This is a theta means now remaining angle will be, it is 90 minus theta. If this is a theta, sorry, this is 90 minus theta, this also 90 minus theta. 90 minus theta and this angle 90 minus theta. That means this angle will be, this will be 2 theta. See carefully. Suppose this is AP2, that is R, and suppose this is C, AC. AC value R, AP2 value R. Okay. Since these two sides are equal, these two angles must be same. That's why this is a pi by 2 minus theta. This also pi by 2 minus theta. Okay. Right. That means this is now 2 theta. Now see what we can do. Work done by that force. So take it as W1. That is now integral F1. I am taking modulus 1220 into ds into cos of the angle between them. Right? Like this we have take from theta equal to, now see carefully, this is angle between displacement vector and force vector. Okay. So when we are taking at P1, force will be towards P2, right? And displacement is along a tangent, along a tangent. So you can see the line joining P1 and P2 makes an angle 45 with a horizontal. That means initial angle 45. So that is what we have to understand. Initially angle 45. When this point reaches P2, then it will be towards P2, means like this. That means displacement along a tangent, force also along a tangent. That means when it is about to reach point P2, angle between those two vectors will be 0. Okay. Now remain just calculation part. Now to get the value of ds, see what we can do. From P1 to C, this arc length will be P1 to C. That is the distance traveled, S equal to R into theta, R into theta. It is now how much? Total value is 90. This is 90. So remaining is now 90 minus 2 theta, 90 minus 2 theta. We want here ds value. So differentiate this. ds equal to R into 0 minus 2 into d theta. R value is 6. It is now minus 12 d theta. Substitute that now here. So taking minus 12 and 20 outside, minus 240 integration of cos theta d theta. Okay. Now simplify this. Then see what we are going to get. So taking that here, W1, that is equal to minus 240 integration of cos theta d theta, that is sine theta. Now take limits. Sine theta, it is now sine 0 minus sine 45. Okay. So minus minus gets cancelled. It becomes now 240 sine 45 1 by root 2. That is now 120 root 2. 120 root 2 joule. Okay, that is our answer. And you can see F3, it is always along the tangent. Okay, and this is not a conservative force, right? So options are, first one, it is A, B, and C, right?